So generally the relative density value gives us the floating or sinking property of the objects. So we finished the relative density of the objects with the help of formula by calculating the mass of the objects, different objects. So that is compared when their volumes are same. But what about the heaviness or lightness of the liquids? So further we have the topic called relative density of the liquids. Suppose I will ask you a question. If you take a small quantity of kerosene or oil, what we use in our cooking, which is used as a cooking oil. Suppose when it is poured on over the water. So we observe that oil will float on the water. Similarly, kerosene also will float on the water. So why it is not sinking inside? So why it does not go inside? The reason is simply we say that oil is lighter than water. But same if you take the milk. When you take the milk, when you pour a drop of milk over the water, then what will happen? So we will expect something that it may float or it may sink. But the real explanation you can tell the floating property or sinking property of the liquids depends on the values of relative density of the liquids. So how can you calculate the relative density of the liquids? So simply we used to take the formula. So the relative density of the liquids can be calculated by weight of the given liquid. So weight of the given liquid, nothing but it may be milk, it may be oil, it may be kerosene or anything. So this is the numerator part is weight of the liquid. Weight of the given liquid we have to write actually. And denominator part is weight of the same volume of the water. So already we are comparing the masses of the objects with respect to water. So mass of the liquids with respect to water. But the thing is we have to take the volume of the liquids should be same. One is given liquid, another is water also a liquid. So that is why we are taking the weight of the same volume is important. The term same volume is very important. Same volume is the occupied place. Suppose if you are taking 1 liter of milk and 1 liter of you have to take the water. So then if you are measuring the 1 liter of milk mass, you have to measure the 1 liter of water mass. So like that, if you want to compare the relative density of the kerosene, what you have to do? You have to take if you take 50 ml of kerosene, then you have to take 50 ml of water only. So now if you take 2 liter of petrol, you have to take 2 liter of water. So that is the concept of the relative density of the liquids. So now in the experiment, you have to measure the masses. The weight is nothing but in the sense of mass only. So mass should be measured with respect to the same volume of the water. So now for that purpose we are conducting simple experiment. So I am taking almost all equal volume of the two measuring jars. So let us suppose these are having almost all equal 100 ml of quantity. This consists 100 ml of liquid. We can pour up to 100 ml. The size of the volume of the liquid in this one will be 100 ml. In this 100 ml. Suppose in the first one I have taken the kerosene. I have taken this kerosene. In this one I have taken water. Kerosene and water. So now our aim of the experiment is measuring the relative density of the kerosene. So for that purpose I am using a common weighing machine because it is available now. So now first initially I measure the empty vessel weight. First initially in the experiment what you have to do? You have to measure the weight of the empty bottle. Okay. So now it is 100 ml. So you have to write 100 ml weight. So weight of the empty bottle now it is grams I am writing. So it is approximately 200 gram. 200 gram. Now I am taking the kerosene, the given liquid, and keeping on the weighing machine. So now it is showing 350 gram. It is showing 350 gram. So now again you have to go for, this is a water, contains water. So now it is showing 450 gram. It is showing 450 gram. So now I am writing weight of the 500 ml water is 450 gram. So if the weight of the quantity is 100, so we have to take 100 ml of water. So the weight of the 100 ml of water is 450. Now you can imagine the 450 minus 200. 450 minus 200 is, it is 250 gram. It is 250 gram. 250 gram is what here? 250 gram is the mass of the 100 ml of water. Now according to our experiment. So initially you have to do this one, because in the denominator part, our denominator we have weight of the same volume of the water. So the mass of the same volume of the water is, now according to our experiment, is 250 gram. So now let us suppose I have taken kerosene. In the kerosene part, weight of the bottle filled with liquid. So now just now what you got? 350 gram. 350 gram. Now weight of the liquid. What is the liquid here? Kerosene. So 350 minus 200. So it will be 150 gram. It will be 150 gram. So now we are going to find the final value of the reductants of kerosene with help of the formula. So what is the numerator? Weight of the liquid. Weight of the liquid is 150 gram by denominator. How much weight of the liquid is water? 250 gram. So 150 gram by 250 gram you have to measure. So now what you get here? So you can cancel 5 3 ja, 5 5 ja. So you are getting 3 by 5. So the 3 by 5 will be equal to 0.6. So you should not write any unit. There is no unit because it is a ratio of the same physical quantities, mass by mass or weight by weight. So then now according to our experiment, so the find out the value according to our weighing machine and